Welcome to our tutorial on linear equations. In this lesson, we're going to discuss how to find a linear equation. In other words, the equation of a line, given 2 points on the line. First, we'll look at some of the common forms used to write equations of lines. Then we'll look at how to use those forms to write linear equations. We will use the concept of slope a lot, so make sure to go back and review that first if you need to. There are 3 main forms for the equation of a line. Standard form, ax plus by equals c, has a, b, and c that are all integers. Now this form is primarily used for giving you the equation of the line, or sometimes you'll be asked to find the equation in this form, but you're really going to have to use one of the other 2 forms first before you can get it to this. So we'll look at this last in order to convert from the other 2. Now the other 2 forms are slope-intercept form. This is the equation y equals mx plus b, and you should recognize m as slope. And then the last one is point-slope form. Now this one's a little bit different, but it's y minus y sub 1 equals m, again our slope, times the quantity x minus x sub 1. So let's first of all look at slope-intercept form a little more closely. You'll notice here we have the equation y equals mx plus b. And as we mentioned, m is the slope. The intercept part of this name is because b is the y-intercept. Now you may ask, what's a y-intercept? Well, an intercept is simply a place where the line crosses an axis. You can see here this line crosses the y-axis, our vertical axis right here, and it crosses the x-axis right here at this point. Now this form doesn't use this point, that's what's known as the x-intercept, but you'll notice here I have this point here labeled as 0b, because since it's on the y-axis, the x-coordinate is 0, but the b tells us what that y-coordinate is. Our point-slope form, we already saw, is y minus y sub 1 equals m times the quantity x minus x sub 1. Now, again, m is our slope, but the point part of this name, it's called point-slope form. The point is because these coordinates x sub 1 and y sub 1 are the coordinates of any point on the line. It could be an intercept, but it could just be any point on that line. It doesn't matter where. So what's really necessary in order to find a linear equation? Well, first of all, you must know a point on the line, and secondly, you have to know the slope. If you aren't given those 2 things, you can always work backwards from that concept. For example, if you're given 2 points, you need to work backwards and think, okay, if I need the slope to get my equation, how do I use those 2 points to find my slope? So our first example, find the slope of the line through the points 3, 8, and 5, negative 2 using slope-intercept form. Now again, our slope-intercept form is y equals mx plus b, and I've color-coded it here to help us notice what part of the equation we're working with as we work out this example. So first of all, we need to figure out the slope. Since we have 2 points, we can use rise over run. Notice we're rising in negative 10, we're going down, and we're running 2. So our slope is negative 10 over 2, which equals negative 5. Once we know that, notice we have the 2 things that we need to find our equation. We have our slope and we have a point. In fact, we have 2 points, and we can pick either one we want to find the equation. Our next step is to find b, and that will help us get the actual equation. So to find b, we use our form y equals mx plus b, and we plug in the m, the slope, and we plug in a point. Now I chose the point 3, 8. 3 is our x-coordinate, 8 is our y-coordinate, so you'll notice I plugged in 3 for x and 8 for y, and now b is the only part of our equation that we don't know. So now it's a simple matter of algebra. I simplify, and then I add 15 to both sides, and I find out that b is equal to 23. So now I can write my equation, y equals negative 5x plus 23. Our next example, we're going to find the equation of the line through the points 2, negative 3, and 5, 4, but this time we're going to use point-slope form. Now as we saw, our point-slope form is y minus y sub 1 equals m times the quantity x minus x sub 1. And you might wonder why I put the x sub 1, y sub 1 in blue. The reason for that is because those are what are eventually going to give us that y-intercept that we saw earlier. So I'm using the same color coding scheme to help us keep things straight. So the first thing that we need to do though here is, you'll notice we have plenty of points, but we don't know the slope. So since we have 2 points, again I'm going to use rise over run. And in this case we had to rise 7 and run 3. So our slope is 7/3. Now we're going to use our form and we're going to plug in that slope and either one of the points. But notice we have y minus 4. I chose to use the point 5, 4, and 4 is the y coordinate. And that equals our slope m times the quantity x minus the x coordinate of that point. Again, I used 5, 4, so I'm using the 5 here. Now it's a matter of simplifying. We distribute the 7/3. We get 7/3 x minus 35/3. And often what you'll do is you'll at least convert this to slope-intercept form by adding 4 to both sides. So that comes out to y equals 7/3 x minus 23/3, or y equals 7/3 x minus 7 2/3. And you can see here, notice our y-intercept is down here, negative 1, 2, 3, 4, 5, 6, 7, and that must be 7 2/3. So we can use a sketch of the graph to make sure our answer makes sense. Alright, so let's look at how we would convert to standard form, as I mentioned earlier. Sometimes you'll be asked to give your answer in standard form. Our standard form is ax plus by equals c, and technically a, b, and c need to be integers. That means they can't be fractions. Looking back at the answer we got from our first example, y equals negative 5x plus 23, this one is actually very easy because we don't have any fractions, so all we have to do is add 5x to both sides, and there we have our standard form, 5x plus y equals 23. For our second example, when we had point-slope form, we have actually a couple of steps that we need to do because we have these fractions involved. So the first thing I'm going to do is get rid of all the fractions, and since I have thirds in both of my fractions, I'm going to multiply everything by that 3. Now if I had different denominators here for some reason, I would multiply by whatever the least common denominator of those would be, because the least common denominator is the least common multiple of both numbers, so both denominators would cancel out. In this case, however, we have to just multiply by 3. We get 3y equals 7x minus 23. Notice the 3's canceled out. Don't forget to be fair to both sides. We multiply the y by 3 as well. We subtract 7x. We get negative 7x plus 3y equals a negative 23. And now both of those equations are in standard form. So we have looked at finding equations using slope-intercept form, finding equations using point-slope form, but there are 2 special cases that are actually really easy if we recognize them. So let's look at the easy ones. Horizontal lines have a slope of 0, as we've seen in our lesson on slope. And in this case, because the slope is 0, the y-coordinate is not changing. So since the y-coordinate doesn't change, we don't care what the x-coordinate is in our equation. So our equation can just be y equals whatever that y-coordinate is. And I used b because in this case it will actually be our y-intercept. The other easy example is when we have vertical lines. Here the slope is undefined, so the x-coordinate doesn't change. Now it's important that you learn to recognize these because, as we'll see later, you cannot use either of our other two methods or other two forms to find this equation. You have to recognize it as a vertical line, and remember, your equation is simply x equals a. And a is just the x coordinate of the points that you know. So let's look at a couple examples of these. We're going to find the equation of the line through the points 2, -3 and 5, -3. You'll notice I sketched it. I sketched the other two as well. And it's a good idea to do this because you can very easily see these two special cases if you always sketch it. Now, if we want, we could go ahead and find the slope. We rise 0 and run 2, and we recognize the slope is 0, and hopefully at that point, at least, we recognize this is a horizontal line. We could actually use point-slope form, as you see here. If I used the point 5, -3, plug a 5 in there, a -3 in there for y1, and I plugged in 0 for my slope, I could do that. If we recognize that both y coordinates are -3, we can simply write down the equation y equals -3. Another example here with a vertical line, we're going to find the equation of the line through the points 5, -3 and 5, 4. Again, you see how sketching it helps us to see very easily that it is a vertical line. If you didn't happen to sketch it or you didn't notice that, when you went to find the slope with a rise of 7 and a run of 0, and you got an undefined slope, hopefully at that point you should recognize that it is a vertical line. Now notice with this, if you try to use point slope form, you're plugging in undefined for m, and that's impossible. That's not a number. You can't do that. So we have to have a better way. We have to recognize that both x coordinates are 5, and therefore we can write down our equation x equals 5. Now that we've seen a few examples, why don't you try some yourself? Remember, find a point in the slope, then plug it in and simplify. And don't forget your forms.